Welcome back to the course Introduction to Green Process Engineering. Today we will have a look at biorefinery technologies. Before discussing the technologies, we will take a look at the biorefinery concept and the input materials used in biorefineries. I will also give some examples of biorefineries. What is a biorefinery? Well, a biorefinery is a facility where a wide variety of biomass is converted into marketable products, including materials, fuels, energy, food, and feed. Here you can see the concept of a biorefinery and the most relevant technologies are summarized. The primary goal of a biorefinery is to provide sustainable and economically viable alternatives to fossil fuels and petrochemical products by employing renewable bio-based resources, by maximizing the biomass yield while minimizing waste. In general, you can think of a biorefinery as the pendant to a conventional refinery that uses crude oil as input material. At European level, biorefineries are considered in the bioeconomy strategy. On the next slide, we will take a closer look at the input materials and technologies used in a biorefinery. The selection of input materials in biorefineries is foundational to their operation efficiency and economic viability, as they dictate the range of products that can be generated. Lignocellulosic biomass, being the most abundant biomass, is the most relevant input material, but also any industrial or agricultural side stream is used as input material in a biorefinery. Lignocellulosic material, such as agricultural and forestry residues, consists of three main parts, namely cellulose, hemicellulose, and lignin. In an economically viable biorefinery, all three parts of the biomass need to be utilized. Also, microalgae are used as feedstock for biorefineries. They present a versatile feedstock due to their rapid growth rates and their ability to thrive in low-quality conditions. Waste-derived feedstocks, such as exhaust olive pommes, brewer's spent grain, or the organic fraction of municipal waste, serve as integral feedstocks in biorefineries. Their incorporation maximizes resource utilization and reduces the environmental footprint associated with waste disposal. Animal remains and food processing waste, such as whey or manure, can be fully integrated into biorefinery operations. By utilizing such materials, biorefineries can harness nutrients and energy that would otherwise be lost, producing value-added products and energy. Also, feedstocks such as jatropha, which is grown specifically for the use in biorefineries, or CO2, are input materials for biorefineries. With that, we also need to discuss challenges that arise when we talk about feedstocks for biorefineries. If we take jatropha as an example, then we see that land must be used for the cultivation. But this land could also be used for the cultivation of food. Challenges that arise with the biorefinery concept are related to the availability, quality, supply chain logistics, and economic viability of these materials. Furthermore, water as an inherent constituent of biomass leads to the need for a water management strategy in biorefineries. In summary, the array of input materials available for biorefineries reflects the broad potential of biomass to function both as a foundation for sustainable energy production and as a source for diverse bioproducts. The ability to integrate different feedstocks into a cohesive production workflow enhances operational robustness and economic feasibility in the transition towards a more sustainable bioeconomy. However, you need to keep in mind that most of the biomass feedstock are already being utilized today and that we have to compete with other utilization pathways. For example, wood is already used in sawmills, in pulp and paper production, but shall also be used in steel production and is a feedstock that can be utilized in a biorefinery. Which technologies are now used in a biorefinery to convert the input material into products? it lies on hand that biorefineries need a variety of technologies to convert the comparably complex input materials into uniform intermediate products that can be used for further processing. Hence, hybrid approaches are used which combine the conversion of complex organic materials into simpler molecules such as sugars, proteins and lipids that can be further converted into the final products. Let us have a look on an exemplary value chain in the bio-based industry, respectively on a biorefinery. Not all processes shown here are necessarily present in a biorefinery, as this is highly dependent on the feedstock. However, at the very beginning of the production process, mechanical and physical processes are used to reduce the size of the input material and increase the specific surface area. For example, if you think of the input material wood, which is present in the form of a tree, then it is clear that we need to decrease the size to be able to process the material. Treatments such as milling, grinding or comminution, but also steam explosion are summarized. Midstream is where the biomass is converted into products. In this process, the final products are formed using thermochemical, chemical or biochemical processes. In general, biomass conversion does not produce a pure product. To give an example, if you think of a fermentation process where sugars are converted into a product, after the final product is formed, some sugars remain in the fermentation broth. The microorganism as well as nutrients are also still contained in the broth. Hence, the last steps in the biorefinery are performed for product purification. Here, mainly mass transfer unit operations are used. The so-called downstream processing uses unit operations such as extraction, distillation, crystallization or alike. What you should know is that the downstream processing costs can be up to 50% of the overall production costs, leading to the need for efficient downstream processes. In another lecture, we will discuss how downstream processing costs may be reduced for lactic acid production. But now let us take a look at a biorefinery example. Bioethanol is the most prominent example when talking about biorefineries. A flowchart of the ethanol production is shown here. After the biomass enters the biorefinery, biomass handling for size reduction is performed, followed by a pre-treatment to get access to the biomass constituents. Enzymatic hydrolysis and fermentation to convert monomeric sugars into ethanol, which is isolated via distillation. The bottom products, consisting mainly of lignin, humins and water, are further utilized for internal and external energy supply. You can clearly see that a biorefinery not only produces one product, as here ethanol, but also, for example, biogas, pellets, steam or electricity are produced. There are a lot of interesting biorefineries that you can have a look at. You can find some links in the additional information. In summary, I showed you today what a biorefinery is, that biomass and waste streams from the bio-based industry are used as input materials for the biorefinery. Also, the competing interests of biomass utilization were discussed. You should now be aware that biomass is a complex raw material and that processing it is not an easy task, but requires efficient technology. Finally, we had a look at biorefinery technologies and an energy-driven biorefinery for ethanol production as an example. With that, I would like to thank you for watching and hope you will also watch the other videos.